look at a problem together like we did yesterday. I'm gonna use Julia to do it, okay? So we're going to find the area under the curve, okay, numerically, okay, numerically. So which means we're gonna draw each rectangle and define the area of each rectangle, and we're gonna combine them, and that become our area under the curve of the part that we want to integrate, okay? So I'm going to share my screen. First thing, I'm going to show you what the lesson is. So Riemann sums is how you find an area under the curve, okay? So this is what they're doing. As you can see, they were finding area of each rectangle, okay? And you will combine them. So rectangle 1, rectangle 2, 3, and 4, you add them together. So total area would be rectangle 1 plus rectangle 2 plus rectangle 3 plus rectangle 4. That gives you the area of entire thing. But as you can see, the rectangle is bigger than rear area because we're adding this much, okay? Those much. So if I do this way, we call it upper sum, okay? Because I found more than the rear areas, okay? And then we can also do, so this case, we're gonna call it upper sum, or upper sum of area, okay? We can do a lower sum also. Okay, lower sum means I'm gonna draw my rectangles. That'll be my first one. That'll be my second one. That'll be my third, my four. So 1, 2, 3, 4. So this is called lower sum. So this total area is again rectangle 1 plus rectangle 2 plus rectangle 3 plus rectangle 4. But this time our lower sum is smaller than the real area because real area is the true area is this curve. But as you can see, there's a small part is not contained. Those part is not calculated with our rectangle. Our rectangle is smaller than the true area. So that's why it's called lower sum. So lower sum and upper sum, which is upper sum was this. Okay, did you see it? The upper sum is more than true area, and lower sum is smaller than true area. So true area is in between lower sum and upper sum. Okay, so if I draw more rectangles, your area gets better and better. All right. So this is what they're doing. How about I take a limit, which means I'm going to have a many rectangles that will give you better estimate. All right. So let me give you let me draw a picture. Okay, Riemann sum lesson, that's what we're gonna do. So let's try with some easy graphs. If I say f of x equal to say x to the third, my graph looks like that. All right, My graph looks like that. And then I want to look at between, say, 1, 2, 3. So I want to look at my area over here. Okay, so if I draw only 2 rectangles, let's look at that. If I just draw 2 rectangles, okay, look at that. If I just draw 2 rectangles, all right, I'm looking at only 2 rectangles. Look at how much space there. All this part is not calculated. I'm going to have a lot of errors. My error is big. All right, but let's see. If I draw more rectangle, then what happened? I decide to draw 4 rectangles. Okay, not 2, but I'm going to draw 4. So I'm going to draw 2 more. Oops. Okay, I'm going to draw 2 more. I'm going to have a 4. Okay, so the red one is n equal to 2. Now I want to do 4, n equal to 4. 4 rectangles. Okay, so I'm going to draw. All right, now, so I have, so now I have 4 rectangles. Now look at that. What happened to my arrow now? It's got bigger. What's the space that does not cover? It's only over here, the tiny little bit. Okay, did you see that? My estimate gets better because I have more rectangles. So can somebody guess? If I draw a rectangle to be, say, 8, am I going to have a better estimate? Approximation? Yes or no? All right, tell me somebody. If I draw 8 rectangles, am I going to have a better answer?
Yes.
Solution. Yes or no?
Yes, ma'am.
Okay, what this test says? Okay. Diavian, what are you asking me?
You know, you said which problems do we have questions about? And I was number 10 from 4.2.
All right, I'll in a minute, okay? All right. So does everybody understand when my n gets bigger? N means a number of rectangles, okay? More rectangles you draw under the curve, your estimate gets better. Okay, I'm gonna draw 8 now. So the green color means 8, so I'm gonna divide again half of each one of them. Did you see it? When I draw the green one, 8 of them, almost every part of the under the curve is covered by rectangles. There's only a tiny bit, which is right here. This tiny bit is not covered. So when I have 8 rectangles and I try to estimate the area under the curve using 8 rectangles, the estimate is very, very good, in other words. Okay, so we are using this theory, okay? This Riemann sum is what that means. Riemann came out with this idea, it's like, hey, draw many, many, many rectangles under the curve. That more rectangles you draw to estimate the area under the curve will be better approximation to the true solution. All right, so what they're doing is, you know how to find area of a rectangle, right? Rectangle is width times height. I mean, the length times width or base times height, whichever, okay? So the formula says, first thing you need to find a width, which is same as I call it h, which minus b minus a over n. My case, I'm using that to be my b, that to be a. All right, starting number is 3, ending number is 3. So my width, it'll be 3 minus 1 divided by, I'm gonna use n to be 8, okay? I'm gonna use 8 of them. So that gives me 2/8, which is 1/4. So width of, if I just draw this rectangle over here, that rectangle, the width is 1/4. Okay, the height, what the length is f of whatever that is, that height is. For example, this case is a 3, is your numbers, f of 3. So if I do 1/4 times f of 3, which is 1/4 times 3 to the third, which gives me 27/4. That is my rectangle area of that last one. This one right here, this last one. All right, but this kind of stuff is better to use Julia to do because you don't want to do this by hand. It's too much work. All right, so I'm gonna change back this into Julia now. So I did some work before you guys came, but anyway. Share my screen. Okay, everybody see my screen? So we're gonna do Julia, okay? So I'm gonna start with the okay, so don't worry about this part. So let's start together. So we're gonna look at the same example. So let's call it our function. Okay, what was your example 3 anyway? Let me see the one that you were talking about. So if I can see the same problem, then I can just use that problem as a example. You said Davian, did you say 4.2 number 10?
Yes, ma'am.
Okay, we're gonna look at that right now. Great. So you asked me very good questions. So this is what you have. Your number 10 problem is f of x equal to square root of 7 times x. All right. Okay, let me share the screen just for a minute, okay? So you know my problem looks like. Okay, that is, okay, this one is a 4.2 number 10. I am very glad you asked me this problem. So this is the picture that you have. Are you with me? So I do not want to do this problem by hand because it takes too long. Okay, so from looking at this picture, what you need to figure out is this. Okay. From this picture, what you need to figure out is you're gonna call it, because we're gonna put this in our Julia to do it. So you're gonna create in Julia, you're gonna do, we're gonna say f of x is equal to square root 7 times x. All right. And then you're gonna say a is equal to, you need to look at the a, where the a starts. A starts with 0, so that is your a. A equal to 0, and you're gonna say b is equal to which number? It ends at 1, so that's your b. All right, how many rectangles do you see? 1, 2, 3, 4. Rectangle 4, rectangle 3, rectangle 2, rectangle 1. So you're gonna say n equal to 4. All right, so lower sum and upper sum. Lower sum means you're gonna draw your triangle, smaller one. So very first one is this, second one is this, and third and fourth. So that is a lower sum. The pink is lower sum. All right, so lower sum starts with f of a 0, f of 0.2, f of a 0. No, it's not 2. It is, how much is this one? 2. So 1 minus 0 divided by 4 give you what? 1/4, which is same as 0.25. So this is 0.25. Next one will be 0.5. Next one will be 0.75. Okay, these are lower sum. Okay, you're gonna use this as your height, length, I mean. All right, upper sum would be what? Which color? Which one? Blue. Like that. Okay, so which means upper sum means it'll be f of 0.25, f of 0.5, f of 0.75, and f of 1. Of course, you gotta all multiply by what? Width. I'm gonna call it h as your width, okay? So when you add them all together, you get your sum. Okay, so I'm gonna do this problem in Julia. So I'm gonna stop sharing this. Okay, so I'm gonna do that problem. Then I'm gonna just type it in here. A equal to 0, which is, okay, use the sharp to make a comment. That's your what? Number. B is equal to 1, which is what? Ending number. And n is equal to which number? 4. What's that mean? We have what? 4 rectangles. All right. Now, what am I going to look for? I'm going to, oh, what is my height? Not height, the width. Okay. H is equal to B minus A divided by N. That is, this is a width. Rectangle. All right, each one of them, I'm gonna write it down so you know what you're doing. So A is the starting number of X, B is the ending number, N is a 4 rectangles. H, I'm gonna use H as my, the width, which is, this is the width of each rectangle. All right, so what I need to do is this, I need to find each area, the very first one. Okay, so I'm gonna do H times f of A, that is my first. This is my first rectangle. Area of first rectangle is equal to what? Equal to this. So this is area of first rectangle. How about I just call A1? So it'd be easy on me. Okay, I just call it area 1. So it says that's equal to a 0, which is we expected. What's next one? I'm gonna do area of 2, second rectangle. That means I'm gonna multiply by, I'm gonna add by h. My second one is I'm multiplying by h, I'm adding by h. All right, so this means this means this. F of, what is my 0 plus 1/4. That's what that means. That's what that means. All right. What's next one? What's area of 3? And the very first one is first rectangle, second rectangle, and all that. So you're adding 1/4. Now I'm gonna adding how many? I'm gonna multiply by the 2 of that. Per rectangle, what that means? I'm adding 1 more of that. Okay, you can just say 1/4 times another word 2. That's what that means. Or you can do 1/4 again, like that. You can think of this like you adding another width. Okay, I am writing down a commentaries so you know what I'm doing. Okay, whenever you see a sharp sign, that means it's a comment. So Julia does not evaluate that part. That's just for my eyes to see what it's doing. It's explanation. In other words, this is your explanation. What am I explaining to you? All right, so I get that. I need to find one more area. That would be my lower sum. So my fourth right, that gives me that number. So my lower sum total lower sum will be what? Area 1 plus area 2 plus area 3 plus area 4. So that would be my answer. 1.37, 124, something, something, something. So all right. All right. Are you guys following me? All right. Ask me questions if you're not following me so I can help you out. Anybody have a questions? Davian, are you following me? This was your question. Are you following me? What are you supposed to do?
Yes, ma'am.
Ethan, are you following me?
Yes, ma'am.
All right. I want to make sure that you utilize programming skill because this kind of stuff you need to definitely use Julia to do it. But you don't want to do this by hand. It's taking too long. It's not intuitive. When you say area 1, area 2, area 3, area 4, then you know what you're talking about. That means you're creating a rectangle areas. Okay, you literally finding area of each rectangles. All right, so I'm gonna find one more area. I'm gonna call it area 5 because that's the upper sum. It's still area of a last rectangle, but I'm gonna use it so this is the last rectangle, I will call it. Okay, so you do that, you get this number. So if you want to find a total upper sum, okay, upper sum means you want to start with area 5, 1, area 4 plus area 3 plus area 2, and you're done. That means, okay, this means looking at from the right. So you count from the right. So 1, 2, 3, 4, and then you're done. So you got 4 rectangles, 5, 4, 3, 2, 1, you're done. So that'll be your upper sum. So let me look at this one, do the screenshot so in case you don't remember this, because I need to show you, I need to go back. I need to go back to your problem so you can see it. I call this one over here, which is 0. Right here is 0.25. Right here is 0.5. Right here is 0.75. Of course, that's 1. All right. So I decided to find, so first one I find here, in here, in here, and here, and here. I found 5 height, 5 length. So this length right here is f of, in other words, a plus 4 times h. Remember, h is equal to b minus a over n. All right, and height for this over here, this height is f of a plus 3 times h. And this height right here is f of a plus 2 times h. And over here, that height is f of a plus h times 1. The last one over here, that height is f of a, well, plus h times h times 0, right? You don't have anything, just the first one. So that's why I just put f of a. So I found when I use a lower sum, okay, lower sum gets f of a plus h times 0, f of a plus h times 1, f of a h times 2, f of a plus h times 3. You adding them, of course, they multiply by h. You adding them. That is your lower sum. Okay, what is upper sum? Upper sum means you're doing exactly the same thing, but I'm gonna only use this. And then I'm gonna add one more. So that becomes upper sum. So this 3 part, as you can see, this part, that part, and this 3 part is used, lower sum and upper sum. These 3 are common that you're gonna use it because they're in the middle. So lower sum has this, that plus middle part, right here, middle part. Upper sum has what? This middle part and plus what? The last one. That's why I didn't have to calculate this part again, because this part I can use it again and again because it's in the middle. Lower sum, upper sum, they both use this middle part. This middle part, you're using it. Excuse me, not that one. Not this one. This one. Those 3 of them, you're using it. All right, so we're using this height, that height, and that height. So is it clear to you now? Okay, I should ask the avian. So this was your questions. Is it clear to you what I'm doing?
Yes, ma'am, I understand.
Okay, would you know what to do with the other problem?
Yes, ma'am.
So let's practice this one, class. I want everybody to do this problem right now on your Julia. And show me your screen. Do number 11. I want everybody to do number 11 in your Julia right now and show me your screen. You can take a screenshot and send it to me. Okay, let's everybody remember, this time I'm gonna call it g of x is equal to 3 divided by x. What is my a? We gotta always tell the program what my a is, my b is. What's my a? That's my a. So a is a 1. What's my b? 2. How many rectangle do you see it? 1, 2, 3, 4, 5. So n is equal to what? 5. So now you need to calculate your h, your width. H is equal to what? B minus a over n. 2 minus 1 over 5, which is 1/5. All right. Now find the area. Put this in your calculator. So what would you do? Very first one, I'm gonna use, this is my first, second, third, fourth, fifth. In this case, I'm gonna draw 6 of them. Okay, I'm gonna draw 6 of them, and then I'm gonna find first 4, first 5 to give you left end. The other 5 give you what? Other end. Okay, so this case actually starting from the left give you upper sum because it has more areas. So you gotta do first one to be what? F of a times h. Second one to be what? F of a plus h times 1 times h. Next one to be what? F of a plus h times 2 times h. One more, f of a plus h times 3. 1, 2, 3. One more, f of a times h over 4. Okay, times h, times h. So that gives you upper sum in this case, because you drawing your pictures like this. Okay. So do that on your calculator. You do this in your Julia and show me. Right. So do that with me. So do your calculator. Do g of x equal to x divided by 3. All right. Do that. For this case, a is a 1, b is 2, n is equal to 5. So h is equal to e minus a divided by n. So I got that. All right, so let's find the first area. Let me tell, just call it rectangle 1 this time, so you know the difference. Rectangle 1 is what? G of a plus h times 0 times h. Next one, I'm gonna change that into 1. And that's my second rectangle. Second one. This is my third rectangle. I gotta find 5 of them. Rectangle 4. Rectangle 5. All right, so I found 5 rectangles. That would give me 5 rectangles that I want to find. So I'm gonna do what? Total area. In this case, this is upper sum. That gives me my upper sum. Okay, I need to do my lower sum, which means I need to do my, I need to find my last one. So I'm gonna say rectangle. Can I call it just a 6? Well, if you wanna call it last. Get that number. So quarter, lower sum is, I'm gonna do rectangle last plus rectangle 5 plus rectangle 4 plus rectangle 3 plus rectangle 2. I'm done. I'm not gonna do 1 because 1 belongs to upper sum only. So you get this. So this is, remember your picture? Was it 3 or 2? 2. Okay, there's 5 of them. The upper sum is this. 1, 2, 3, 4, 5. That's your upper sum. Okay, so my upper sum that doesn't make sense. My answer should be upper sum should be bigger number than a lower sum. So where did I make a mistake? Well, class, look at my calculation and then see where did I make a mistake. Because remember, I just found, according to my picture, the lower sum is, according to my picture, this is more than the real answers because I am going over my graph. See this much, this is much more, that much more is included right there. So starting with the 1, going down this way, I will have a more than a true answer. So what is wrong with my equation? Did I put my equation wrong?
You used the wrong equation. It was 3 over x.
Oh, thank you, thank you. That makes sense. Thank you. So that makes sense. I was wondering why it's not working, so it makes sense. Thank you. Okay, so I need to correct. So g of x is equal to what? 3 over x. That's the correct answer? Okay, 3 of x. So I have that. Now I need to calculate everything again. Starting with the first one. Fifths is fine. By the way, you use upper and lower, upper and page up to go up. So you get to do 4, 4. I need to do 3 again. I I need to do 2 again. So I did 1, 2, 3, 4, 5. I need to do the last one. All right, so I'm gonna find the upper sum. Okay, lower sum is that. Upper sum is that. Yeah, now it makes sense. So upper sum is 2.23 and lower sum is 1.93. All right. Does it help you what I'm doing? Because when you do your homework, you're gonna do the same thing like I do. So you don't have to do individually. You don't have to calculate individually, but let the Julia does for you. You just program to Julia. You are programming this, okay? All these things you're programming. And then Julia does for you. And then later on, if you want to, you can write a function. So let me write it right now. So everybody look at this. So you can have this. So you can say function, say Riemann sum, and that goes to what? Give you function name, A and B, and then N. Okay, I didn't spell right. Function. Okay, and then say H is equal to B minus A divided by N. That's my width. All right, so what do I want to do? I want to find 4. I'm going to use for loop. 4i in 1 to n. And I want to calculate. By the way, you have to initialize your first area. So you may use this, if you want to, you may use this. So I'm going to do each rectangle area is equal to f of a plus h times I, okay, times h. That means I'm gonna starting with, so actually I wanna starting with the very first one. Okay, so I'm starting with a 0. In other words, remember with this part right here,
Question mark, please.
I'm starting with a 0, h, a plus h0. So h0 means this one right here. 1 minus 1 give you 0. Okay, and then say area is equal to area plus rectangle area. Let's print this. So what does it giving me? By the way, I'm doing this. This is what you're gonna do on your semester project. Print stuff so you can see what's going on, whether you're making a mistake or not. The print is kind of like a debugging. So total area is, I'm going to total lower sum is, what is it? I'm going to do area what? So I'm going to do this a little bit later. I'm just going to do that for now. I'm going to just find each area. So I'm gonna use G1, 2, and 5 rectangle. So it gives me each area. Very first one is 0.6, next one is 0.5, next one is this, next one is that, next one is that. But I didn't add up all together yet. Okay, so if I want to, I can also add it, put it in here. I can also print. Okay, so I want you to watch me what I do. Whenever you want to just do it, enter it. Okay, that give you next line. Okay, so now I calculated, they're giving me total area is 6. Now they're accumulating for me. Total area is 4, and total area is this, and they're giving you each area. All right, so I want you to work with me. Okay, I want you to play with this. So you can do your project using like this, and you can also use Julia for any kind of numerical things you have to do, use Julia. So just have practice coding. It will be good for you. All right, I mean it. It'll be good for you. You will further your career having this coding skill. So anytime you have this, try to use Julia instead of using a calculator. So you have this mindset that you're gonna program. But anyway, my Riemann sum is not completely correct because it's giving me a more than n. But I can give you correct functions tomorrow. But just understand, you can do like this. Do one at a time like this, what we did here. All right, just like that. Do one at a time. Define your function, define your A, define your B, define your N, define your width, and use this like that to find your solutions. All right, any questions from today's homework? I mean, today's lesson. Anybody have questions from today's lesson? All right, if you are here, say I'm here, write it down, say I'm here, so I can do your attendance. Okay, anybody have a questions? Let me ask you one more time. Anybody have a questions? Is everybody good? All right, so do your homework using Julia if it's a numerical way to do. Okay, and tomorrow I'm gonna do, I'm gonna find area, true area using intervals. Okay, that's what I'm gonna do too. So tomorrow, I'm not done with the 4.3 today because I haven't done definite interval. Definite interval is how you find area given to a limit, upper limit and lower limit. So that's what I'm gonna do tomorrow. So hopefully I will finish almost everything. Let me see my lesson. Yeah, so there's only a few left in 4.3. So I will probably do 4.3 and 4.4 tomorrow. And then I will do 4.5 on Thursday. So we'll be done with the 4 point. So you can take your exam next week. All right, and your project is not due today. I postpone your project due date to the end of this month, which is October 31st. And your PRTL leaders know what to do, so work with them, all right?